All right, what you're going to see here is, again, how this all builds from what we just finished doing. So if you struggled on the factoring part, then you need to really recover that material, whether it's asking me questions, whether it's finding some practice stuff online. But you are expected to know how to do the factoring by hand, because what you're going to do here in the rest of this section and really the rest of this chapter, as well as the next chapter when you're solving equations, is you are going to factor. Right? There's 2 steps to simplify rational expressions, very basic. Step 1, you're going to factor both the numerator and denominator of the fraction. Okay, you're going to factor it completely. Once you factor it, you're then going to cancel any common factors. Okay, now, the final thing is, again, where the way that we're going to talk about it differs slightly from how you've done this before, in the same manner as the absolute values with the radicals. You know, when you simplify a radical and you have to test for absolute values, when you cancel common factors, you have to identify domain restrictions. All right, notice I said implied domain restrictions. Okay, you don't have to identify a domain restriction if it's apparent in the form of your expression. Okay? What you need to do is identify domain restrictions that got canceled out through the process of simplifying that expression. Okay, so here's the example I'm going to go through. Okay, if you take this expression here, what can you factor out of the numerator? You take out a common factor of 3, leaving 2x minus 1. And in the denominator, now, the denominator, it's not 2 prime numbers as your leading coefficient and your constant, but there is a guide. What's probably going to cancel in this problem? Probably going to cancel this factor. Again, not a guarantee, but it's a pretty good guide, and it may guide you into a trial and error or reverse FOIL method of factoring this. So if, assuming that 2x minus 1 is one of the factors that gives you this product when you FOIL, remember the f and the l, and then the outer plus inner products will have to equal the 4x. Okay, so if the first terms have to multiply to get 4x squared, what would this other first term of the binomial factor have to be? It would have to be a 2x. And then what other factor would give you a product of negative 3 plus 3? Now again, it's an easy way to try the trial and error. You don't have to do it this way. You can rewrite the middle term if you want, or you can do trial and error. But let's test this and see. Is the outer plus inner product going to equal a positive 4x? 2x times 3x is 6x. Minus 2x, does that equal 4x? Yeah, so it works. I would suggest you use trial and error if it seems that you can, if the problem seems to lead you in one direction. And now again, if you had done the rewrite the middle term, you could have factored that as well. But here, when we cancel, go to step 2 and cancel our common factors. Again, why do we cancel them? What does canceling mean? It doesn't mean they disappear from the number. Yeah, what is anything divided by itself? 1. So it just has a value of 1. So the canceling, it doesn't mean that they are completely disappear from the expression. And this is going to come into play in step 3. Okay, they're not canceling like disappearing. They're just canceling because they have a value of 1. And so when you simplify this, these two binomials over one another has a value of 1. So all you're left with is a 3 in the numerator and a 2x plus 3 in the denominator. Okay, so here is your simplified fraction. Now when we move down to finding the implied domain restrictions, we see the restrictions that are directly identified, right? What do you know in this simplified form that x cannot be? You know from this form right here, x cannot equal. And again, the easiest way to do it is just take the opposite of the constant, negative 3, and then divide by the numerator or multiply by the reciprocal of that coefficient. The reciprocal of 2 is 1/2, so if you multiply by 1/2, There's your restriction. You know that x can't be negative 3/2. So when we write our answer, you don't need to include that restriction. It's apparent from the problem. So you don't include the domain restriction if it's apparent in the problem. You do have to include any domain restriction that gets canceled out through the simplification process. So there was another value in this original form, right here, that would have given us division by 0. What was that number? And so again, take the opposite of the constant, 1, divide by or multiply by the reciprocal, 2. So you know that x can't be 1/2. Now, is it apparent from this simplified form that x can't be 1/2? No, but you have to write that restriction down because, again, this factor didn't disappear. It just got canceled with a value of 1. So you still have to maintain the original restrictions. And the original restrictions were x can't be negative 3/2 and it can't be positive 1/2. The negative 3/2 is still apparent. The one that got canceled or hidden, so you have to infer it from the original problem, is that x can't be the 1/2. Corbin?
If you had a problem where nothing canceled out, you wouldn't have to write any domain restrictions because everything would be implied.
Yes.
You only have to write stuff that isn't implied because you canceled it out. That's the only case.
Yeah. So let's say you do. Let's take that question, and we're going to compare it to a couple things here really quickly. All right. So if this is your original problem, and I'm just using this so I don't have to go through the factoring part of it, but just the canceling factors. What cancels here? This x and this x, right? So your simplified form is 2 over 5x. Now, there is a domain restriction, right? What do you know x can't be? X can't be 0, and that's directly shown in this. It's apparent from the form of your answer. Now, we did cancel a factor out of the denominator as well, right? An x. So do we have to write x not equal to 0? No, because that's already apparent. So you don't need to write any restrictions here. And now, on the other side, if we had flipped this around and simplify, now this x cancels with this one. Our answer is, oops, let's say this is a 2 still. Our answer then is 5/2 x. Okay. When you look at this, anytime a factor gets canceled from the denominator, you have to check and see, is that domain restriction still apparent in the final answer, the simplified form? So we saw here that x can't be a 0 in the original form. Is that shown in our simplified form? No. So we have to identify x cannot equal 0 from that form. And does that make sense when it has to or doesn't have to be written? All right, let's go ahead. I want you to try the 3 sample problems. This is on page 31. Sample problem number 2. And I want you to see if you can reduce each of those.